Okay, let's give you guys some more practice. So here, find the limit of tan of x. Find the limit of tan of x over x as x approaches 0. So when you look at the graph, it will look like this. So from the left-hand side, as you approach x equals 0, it will head towards here. And then from the right-hand side, it will head towards here. Dead on 0, it's undefined. So from the graph, you can see that it's heading towards 1. But in reality, you're going to get a problem like this, but you're not going to be given a graph. So find out the limit of this as x tends to 0. As a clue, hang on, just remember that when you look at a circle of radius 1, tan tan of x here, tan of x equals, well, remember that this height here is sine of x, and this length here is cos of x. Well, tan of x here equals this, and remember this has to be buried inside your mind. You must know this. You must remember this. Okay. Well, in order to do this, this is your clue here. Okay. So press pause and have a go. Okay. So to do this here, visualize this tan of x as this bit here. So put this into here. So instead of saying tan of x over x, just visualize it as sine of x over cos, and basically you've got a fraction within a fraction. But whenever you get a fraction within a fraction, it looks quite ugly here. This thing looks ugly, a fraction within a fraction. So visualize it as a number here. So you can imagine this as being a number divided by x. So this number divided by x. So visualize it like this. And when you divide a fraction, it gets multiplied to the bottom. So sine of x, well, it would be cos of x. It would be x times cos of x here. So visualize it as imagine it as a number divided by x, and then it gets multiplied to the bottom. So it would then become this. Okay, and then hang on, and then split this up. So split it up like this. Split it up into two separate fractions. So you've got one fraction here and another fraction here. So when you multiply these two fractions together, it will indeed give you this, because look, top times top, that will give you sine x, and then bottom times bottom, that will give you x cos of x, which is the same as this. Okay, basically split this up here into two separate fractions, and then take the limit of this and take the limit of this. So basically you can break well so the limit of this whole thing here is the same as you taking the limit of this, timesing find whatever the answer of this is, the limit of this, and then multiply it with the limit of this. That's the same as you finding out the limit of the whole thing here. So remember that the limit of this here, well, you must know this. Must know here that the limit of sine of x over x as x tends to 0 equals 1. And we've done many videos on this here. So you must know it by now. So the limit of this here is 1. And the limit of this here, well, if you put 0 into here, nothing breaks down, because if you look at the cos of x, the graph cos of x, it will look something like this. And you see, when x heads towards 0, cos of x is actually 1. Cos of x is 1. So this bit here will be 1. So it's really 1 over 1. Nothing breaks down. So for this bit here, you can simply put 0 into here, because nothing breaks down. 1 over 1. So it's only problematic if you have a 0 here. If say this is sine of x. Well, my point is that put 0 into here, nothing breaks down. So the limit of this here, as x approaches 0, it is indeed 1. So the limit of this is 1. The limit of this here is 1. So get 1 times 1, that will give you 1. So overall, going back to our original graph, hang on. Going back to our original graph, you can see that the limit is indeed 1. Okay? But that on 0 is undefined, but the limit is 1.